Hey kids, today I'm just going to run you through some examples for sections 4.2, and then I'm going to look at 4.3 and 4.6. These are just some examples that will help you on the upcoming test that you're going to take over Chapter 4. So these are in your workbook. So if you picked up your yellow workbook, this is on page 42. If you didn't pick up your yellow workbook, that's fine. Just watch me as I'm going through these because this will help you again for the test that you're going to take over Chapter 4. Okay, so when you have a giant puzzle like this and you're wanting to find all of these angles, I'm going to kind of move it over. I'm going to go find all the angles, and then obviously you can go back and fill in the answers. But let me show you how to do something like this when you're looking for all of these different angles. Okay, so the way that I always start is I look for vertical angles or linear pairs that might help me. So right away I notice that these are vertical angles, so this angle would be 36 because vertical angles are congruent. I also have another pair of vertical angles here, so if this one is 65, then angle 3 is 65. Then I start looking and saying, okay, well, if I want to get angle 1, that is an exterior angle. These are the remote interior angles, so I can add the 68 plus the 36 together, and I can get 104 for angle 1. Keep in mind you can also subtract from 180 and then do a linear pair. So now I have angle 1, and I have angle 3. So I'm going to go over here and try to get angle 2. This is a triangle. It's going to add up to 180. So I'm going to take 180, and I'm going to minus the 36, and I'm going to minus the 65 that I already have, and what's left over is going to be 79. So now I have angle 2. All right, now I'm going to look for angle 4. So if you look at these together make a straight line. It's not really called a linear pair, but it's kind of like a linear group of angles, the three of them. All together, all three of those need to add to 180. So I'm going to take 180, I'm going to minus the 65, I'm going to minus the 70, and what's left will be the 45. So all of those have to add up to 180. Now I'm going to come over here, I found angle 4, and I'm going to find angle 5. So I could do a linear pair and then subtract from 180, but I'm going to use my exterior angle theorem. The exterior angle is equal to the sum of the remote interior angles. So if I take 118 and minus that 45, I'm going to get 73. Then those angles would add up to the exterior angle. So now I have angle 5. Okay, now I'm going to look to find angle 6. Angle 6 is an exterior angle, and these are the remote interior angles. So if I just add 65 plus 82, I'm going to get the exterior angle, which is 147. The other option is I could subtract from 180 to get this angle and then do a linear pair. So that would give me all of these answers if I went and filled them out. Just keep in mind that you want to use your vertical angles. You can also do linear angles or a linear pair, and then triangles adding up to 180, and then remote interior angles add up to equal the exterior angle. So that's what you'll do on one of your giant puzzles that you might have. I can also do this one for you if you'd like to see one more example. This is a triangle that adds up to 180. So the other thing I want you to know is that these are acute angles of a right triangle. So one of your corollaries says the acute angles of a right triangle are complementary. So all I have to do is take 90 minus 64, and I get 26. Another option is just subtract these two from 180. Okay, now go down here. Here's another triangle. The acute angles of a right triangle are complementary. So I'm going to take 90 minus 58, and I'm going to get 32. So that's another example of like a little puzzle. It's not as big as the other one. All right, now we're going to go to page 44 in your yellow notebook or your workbook. I'm going to do this example with you, and if you don't have your workbook, just follow along. So this is called a congruent statement. We learned that in our notes, and the order of the congruent statement matters. For instance, if I want to find x, I come over here and I notice that angle A has an x on it. So angle A is in the first position. It is going to be congruent to angle P, which is also in the first position. So I come over here and I notice that P is 100. Those two angles have to match because they match up in the congruent statement. They're called corresponding angles. So I'm going to set 2x plus 4 equal to 100. I'm going to solve this, and when I do 96 divided by 2, I get 48. So I know that x equals 48. Okay? Now, if I want to find y, then what I'm going to do is I'm going to go to my picture, and I'm going to see where the y is. Y is on segment DC. Okay, let's see. DC is the third and the fourth letter. So I come over here and I match up. RS is the third and the fourth letter. That means I got to go over and find its corresponding side. These two go together, which means they have to be congruent since the polygons are congruent. So I'm going to set 3y minus 3 equal to 12, and that's going to be 3y equals 15, so y would be 5 when I solve that. So that's what you do when you have a congruent statement. You just have to make sure you match up all the pieces based on where the letters are so that you know what equations to set up. Okay, the last one I'm going to do, last set, is on page 49 in your yellow workbook. It's these 4 questions. If you don't have your workbook, just follow along. This is going over isosceles and equilateral triangles. So one thing that I went over in the Edpuzzle notes with you is if you have an isosceles triangle, then your base angles have to be congruent to each other. So if this base angle is 60, this base angle is 60. So they want us to find angle ABC, so that the measure of angle ABC is 60 degrees. Now that just is a coincidence. This ends up being equilateral also, but whatever these base angles are, they have to match. If the sides match, then the base angles will match also, but they don't always have to match the vertex angle. Okay, next, this is called a vertex angle. It's at the top of your triangle. This is an isosceles triangle again, so that means these base angles have to match. So if these base angles match, I can take 180 minus the 40, that is the vertex angle. I have 140 left, and then I'm just going to divide by 2. That's because each of these angles is going to match. So 140 divided by 2 is 70. That means this angle is 70 and this angle is 70, again, because the base angles have to match. So they want angle EDF. The measure of that angle is 70 degrees. So the moral of the story is, if your triangle is isosceles, then the angles that are opposite those sides that match, those base angles have to match. But they don't usually match that vertex angle. And the vertex angle is the one that's not the base angles. All right, now go to number 7. So 7 is the converse of the isosceles triangle theorem. The converse says if your base angles match, then your sides match. So it's the opposite of what we were doing here. If your sides match, then your base angles match. This is if your base angles match, then your sides have to match. So we're just going to make an equation where we set those equal to each other and we solve. So this is going to be x equals 14. So that means when x is 14, both of these sides will match. Okay, come over here. This one is an isosceles triangle, and it's a right triangle, but let's just look at the fact that it's isosceles. If the sides match, then these base angles are going to match. So if that one's marked 2x plus 3, then this one will also have to be 2x plus 3. They have to match each other. So you can add them up to 180 if you want, but here's a shortcut. If you know this is 90, then these are going to be complementary because the acute angles of a right triangle are complementary. So you can add these up to 90, or you might even notice that these base angles, since they match, each of them would have to be 45. So the fastest way is to set one of them equal to 45, but there are really 3 ways to do this. So this would be 2x equals 42, and then that would be x equals 21. So those are some examples of your isosceles triangles. I'm just going to draw one other little one over here for you to look at. Sometimes they'll give you a picture like this, and they'll say it's isosceles, and then they'll tell you that this is 60. Well, I guess this is what we were doing over here. Keep in mind that if you know the base angles match, then you can find this other angle by subtracting from 180. Now it's not just isosceles, it's actually equilateral. So something to keep in mind is if it's equilateral, it's equiangular, and if it's equiangular, it's equilateral. And the other thing to remember is that if it's equiangular and equilateral, the angles will all be 60 degrees. Okay, those are just some quick little practice questions that will help you hopefully do better on the chapter test that you guys have coming up.